Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we have been provided with an isometric 3D projection of a solid into which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection, and using the constructional details available with us through this 3D isometric projection of the engineering object, we are going to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of the solid. Now, in order to obtain the orthographic projections of this engineering object, we are required to evaluate the dimensions of the front view face, the top view face and the right hand side view face of the solid. Now, as we are going to look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 80 millimeter, while the height of the solid happens to be 60 millimeter. So the dimensions of the front view face of the solid will be measuring 80 millimeter by 60 millimeter. Now when we are going to look at the solid from the top, so once again we observe that the width of the solid happens to be 80 millimeter, while the depth of the solid, it is equal to 70 millimeter. So the dimensions of the top view face of the solid will be measuring 80 millimeter width and 70 millimeter depth of the solid. When we are going to look at the solid from the right hand side view orientation, so we observe that the depth of the solid happens to be 70 millimeter, while the height of the solid, it is equal to 60 millimeter. So the right hand side view face of the solid will be measuring 70 millimeter depth and 60 millimeter height of the solid. So with this information regarding the three faces of the solid, so we are going to proceed to evaluate the front view, top view and the right hand side view orthographic projection of this engineering object over here. Now in order to obtain the orthographic projections of this solid, we have drawn the XY reference line, the X1, Y1 reference line, and we have also drawn a transfer line originating from the intersection of the XY reference line and the X1, Y1 reference line. This transfer line happens to exist at an inclination of 45 degree with respect to the XY reference line, and this transfer line we are going to use in order to transfer the distances alongside the depth of the solid from the top view projections into the right hand side view projections over here. Since we are going to obtain the orthographic projections of the solid into the first angle projections, so the front view projections of the solid will be obtained above the XY reference line, the top view projections of the solid will be obtained below the XY reference line, and the right hand side view projections of the solid, they will be obtained on the left side of the front view projections above the XY reference line. So now let us proceed to evaluate the front view orthographic face of the solid over here. So now we have drawn two vertical projector lines separated by a distance of 80 millimeter, which happens to be equal to depth of the solid over here. And these two vertical projector lines, we have appropriately extended them into the top view projections as well, because we know that into the top view projections, once again the depth of the solid will be required as 80 millimeter over here, and now we know that the height of the solid, it is equal to 60 millimeter. So now we have drawn a horizontal projector line at a distance of 60 millimeter from the XY reference line into the front view orthographic projection view, and we have extended this horizontal projector line into the right hand side view projection area as well, because we know that into the right hand side view projections as well we are going to require height of the solid equal to 60 millimeter. Now into the top view face, we know that the width of the solid happens to be 80 millimeter, so which we had obtained by extending these two vertical projector lines from the front view face over here. Now into the top view face, we have drawn two horizontal projector lines which are separated by a distance of 70 millimeter, which happens to be equal to depth of the solid over here. So this is the depth of the solid. Now these two horizontal projector lines, once we mark them into the top view orthographic projections, we have been able to obtain the top view face of this solid measuring 80 millimeter width and 70 millimeter depth of the solid over here. And these two horizontal projector lines we have appropriately transferred into the right hand side view orthographic projections as well, such that we have transferred this depth of the solid from the top view projections into the right hand side view projections over here. So this way we have been able to obtain the right hand side view face of the solid measuring 70 millimeter depth of the solid, which we have transferred from the top view projections, and 60 millimeter height of the solid, which we have obtained from the front view projections over here. So now let us proceed to evaluate the front view orthographic projections corresponding to this engineering construction. So now as we observe the solid from the front view orientation, so we observe that this solid, it is carrying a rectangular slot at the base of the solid in such a way that this rectangular slot, it starts at a distance of 20 millimeter from the right hand side face of the solid, and this rectangular slot, it is ending at a distance of 20 millimeter from the left hand side face of the solid. So as we look at the solid from the front view orientation, so from the right hand side face of the solid we have marked a distance of 20 millimeter, and we have obtained a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view orthographic projections as well. Similarly, corresponding to this vertical edge of this rectangular slot which is lying at the base of the solid, we know that this distance of this vertical edge of the rectangular slot, it happens to lie at a distance of 20 millimeter from the left hand side surface of the solid. So now we have marked a distance of 20 millimeter from the left side face of the solid, and we have obtained a vertical projector line into the front view projections, and this vertical projector line we have appropriately extended into the top view projections as well. And further we know that we can divide this solid into two elements. Element number one, it is a horizontal wave which is lying at the base of the solid. Then there is a vertical inclined wave which is resting on top of this horizontal wave over here. So this we are going to term as element number 2. So into the element number 1, we have already worked out this rectangular hole location over here. Similarly, corresponding to the top surface of this horizontal wave, we know that this distance of the horizontal wave from the right hand side face happens to be equal to 40 millimeter. So now from the right hand side face of the solid, which is this face of the solid, we need to obtain the edge corresponding to this horizontal web over here. So now we have marked a distance of 40 millimeter from the right hand side face of the solid, and we have obtained a vertical projector line into the front view orthographic projections, and we have appropriately extended this vertical projector line into the top view projections as well. Now we also know that corresponding to this horizontal web at the top surface, there is a rectangular slot which is available towards the right hand side view face of the solid over here, and this width we know it is equal to 40 millimeter, and we know that there is a web over here which is having a uniform thickness of 15 millimeter. So this depth is 15, this depth is also 15, and this width is also 15. So if this width happens to be 15 millimeter, so the width of this rectangular slot will be equal to 25 millimeter, because this distance happens to be 40 millimeter. So now from the right hand side face of the solid, corresponding to this rectangular slot which is available into this horizontal web or the element number 1 towards the right hand side face of the solid, so we know that this width it is equal to 25 millimeter. So having marked this distance of 25 millimeter from the right hand side face of the solid, we have obtained a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections as well. Now another thing we observe over here, corresponding to this element number 2, this is going to be an inclined surface over here, and this inclined surface will be starting from this point, it will be ending at this point at the top. So this point lies at the top of the horizontal wave, this point lies at the top of the solid over here. Now we know that the location of this point can be evaluated when we move at a distance of 15 millimeter from the left face of the solid over here at the top portion of the solid. So now from the left hand side face of the solid at the top, we have to evaluate 15 millimeter distance from the left hand side face of the solid, and at a distance of 15 millimeter from the left hand side face of the solid, we have obtained a vertical projector line, and we have extended this vertical projector line into the top view projections as well. So this point will be providing us with the location of the top surface of the inclined face of this angular web over here. Now we have evaluated all the dimensions alongside the width of the solid. Now corresponding to the different elements of this engineering construction, let us evaluate different dimensions into the front view alongside the height of the solid. So we know that this rectangular slot, it is located at a height of 5 millimeter from the base of the solid. So from the base of the solid, we have marked a distance of 5 millimeter, and we have drawn a horizontal projector line into the front view projections, and we have appropriately extended this horizontal projector line into the right hand side view projections as well. Now we also observe that the height of this horizontal web happens to be 30 millimeter, while this height of this rectangular slot has been provided to us as 15 millimeter. So this distance will also be equal to 15 millimeter. So now we have marked distance of 15 millimeter from the base of the solid, such that this top surface of the rectangular slot can be obtained into the front view projections over here. So at a distance of 15 millimeter from the base, we have been able to obtain a horizontal projector line into the front view orthographic projections, and we have extended this horizontal projector line into the right hand side view projections as well. Now corresponding to this height of this horizontal wave, we know that this distance happens to be 30 millimeter. So at a distance of 30 millimeter from the base of the solid, we have obtained a horizontal projector line depicting the top face of this horizontal web, which is our element number 1. And this horizontal projector line we have obtained appropriately into the front view projections, and we have extended it into the top view projections as well. Now corresponding to this horizontal surface of the element number 2, which is a vertical inclined wave, we know that at a distance of 20 millimeter from the top, this horizontal surface will be available with us. So now we are going to mark a distance of 20 millimeter from the top surface of the solid, and we are going to obtain a horizontal projector line into the orthographic front view projections, and we are going to extend this horizontal projector line appropriately into the right hand side view projections as well. Now we have been able to evaluate the location of different elements corresponding to this engineering object. Let us now evaluate different segments of the solid which will be visible to the observer from the front view orientation. Now we can check, as the observer is going to look at the solid from the front, this vertical face which is lying onto the front side of the solid, this will be parallel to the vertical plane over here, and since this vertical face will be parallel to the vertical plane, so we are going to observe the true shape projections corresponding to this vertical face into the front view projections over here. And this is the horizontal surface which is lying at a distance of 20 millimeter from the top surface of the solid, but this horizontal surface is not visible to the observer from the front view orientation. So we are going to obtain a hidden line edge view projections corresponding to this horizontal surface into the element number 2 over here. Now we also know that there is a rectangular slot over here. So we know that this height is 15 millimeter, whereas this width is equal to 25 millimeter. So this is 25 millimeter and this is 15 millimeter. So once again, this rectangular slot, it will not be visible to the observer from the front view orientation. So we are going to observe a hidden line projections towards the right hand side face of the solid into the front view projections over here. So this way we have been able to obtain the orthographic front view projections of the solid. Now let us proceed to evaluate the top view projections of the solid. Now as we are going to look at the solid from the top, so we observe that corresponding to element number 1 into the top view projections, now we have already discussed that this top surface web, it is having depth is equal to 15 millimeter over here. So from the rear surface, we have marked a distance of 15 millimeter and we have obtained a horizontal projector line into the top view projections, and we have appropriately transferred this horizontal projector line into the right hand side view projections as well. Similarly, we know that corresponding to the top surface of the element number 1, the depth of this web, it happens to be 15 millimeter from the front face of the solid. So from the front face of the solid, again we have marked a distance of 15 millimeter and we have been able to obtain a horizontal projector line into the top view projections, and once again we have transferred this horizontal projector line into the right hand side view projections over here. Next, we also know that corresponding to this element number 2 top surface, from the front surface, this top rectangular portion, it is having depth is equal to 25 millimeter. So now from the front face of the solid, we have measured a distance of 25 millimeter and we have been able to obtain a horizontal projector line into the top view projections, and we have appropriately transferred this horizontal projector line into the right hand side view projections over here. Similarly, corresponding to this rectangular surface appearing toward the rear face of the solid, we know that the depth of this rectangular top surface is once again 25 millimeter. So now from the rear face of the solid, again we have marked a distance of 25 millimeter and we have been able to obtain a horizontal projector line into the top view orthographic projections, and we have appropriately transferred this horizontal projector line into the right hand side view projections over here. This way we have been able to obtain different dimensions into the top view orthographic projections. But one thing we need to remember over here, into the top view projection, this location has not been evaluated thus far. So now we know that from the front view projections, we knew the starting point of this inclined surface over here. We knew the end point of the inclined surface over here. But this location had not been provided to us. So now, as we had obtained the orthographic front view projections over here, so we know that the location of these 2 points, it is provided to us at this particular position over here. So what we have to do now, from this point we have to draw a vertical projector line which is going to indicate the location of these 2 points into the top view orthographic projections over here. So now from this point of the front view orthographic projection, alongside this inclined surface available over here at a distance of 20 millimeter from the top surface of the solid. So we have drawn a vertical projector line into the front view projections, and we have appropriately extended this vertical projector line into the top view projections over here. Now let us evaluate the different faces of the solid which will be visible to the observer from the top view orientation over here. So as the observer is going to look at the solid from the top, we can check the outer boundary of the solid will be visible to the observer. So this is the outer boundary of the solid which is visible to the observer from the top view orientation over here. Now besides this, these 2 true shape rectangular surfaces, they are also visible to the observer from the top view orientation, and we know the dimension of these rectangular faces corresponding to element number 2. They are having width 15 millimeter and depth 25 millimeter. So one rectangular surface is available towards the rear face of the solid. Another rectangular surface is available towards the front face of the solid. So the true shape corresponding to this top surface rectangular surfaces, they are visible to the observer from the top view orientation. Why? Because these 2 rectangular surfaces at the top, they happen to be parallel to the horizontal plane. So the true shape projections, they have been obtained into the top view projections over here. Similarly, corresponding to this horizontal surface which is again parallel to the horizontal plane, so we can check, we have drawn this vertical projector line. So these 2 points we have been able to identify corresponding to these 2 locations over here. So now this is a horizontal surface once again which is parallel to the horizontal plane. So once again the true shape of this horizontal surface has been obtained into the top view projections over here. And now another thing we need to observe over here, that corresponding to this rectangular slot which is available at the top surface towards the right hand side face of the solid, we will be able to obtain the true shape of this rectangular slot, because this horizontal surface again happens to be parallel to the horizontal plane over here. So this way we have been able to obtain the true shape projections corresponding to the rectangular slot which is available with us on the top face on the right hand side portion of the solid over here. Another thing we should observe over here, corresponding to this rectangular slot which is available over here at the base of the solid, So these two edges, they are not visible to the observer from the top. So we will be able to observe dotted line projections corresponding to the rectangular slot which is not visible to the observer from the top view orientation over here. Now another thing we need to observe over here, that corresponding to this inclined surface, we are going to obtain an apparent shape projection of this inclined surface into the top view projections over here. So we can check, this is a bigger inclined surface which is available with us into the isometric projections, but since the surface happens to be inclined with respect to the horizontal plane into the top view projections, we have been able to obtain a foreshortened, reduced or apparent shape projections into the top view projections over here. Now we have been able to complete the top view projections corresponding to this engineering object. Now in order to obtain the right hand side view projections, as we are going to look at the solid from the right hand side view orientation, now we will observe that we are going to obtain the boundary of the object as it is shown over here. So this boundary of the object will be visible to the observer from the right hand side view orientation over here. Now we know that corresponding to this right hand side view face of this object, we are going to obtain the true shape projections of this vertical surface appearing towards the right hand side face of the solid. So this is the true shape projection which we have been able to obtain into the right hand side view projections. Why? Because this surface happens to be parallel to the profile plane. Similarly, this vertical wall of the rectangular slot, this will also be visible to the observer as a true shape projection over here. So this surface, it is also projected as a true shape. It represents this surface of the rectangular slot. This U-shaped surface available on the right hand side portion of the solid, it is also visible to the observer as a true shape. Whereas this inclined surface which is visible to the observer from the right hand side view orientation, because this inclined surface is not parallel to the profile plane, so we are able to observe the apparent shape projections corresponding to this inclined surface in the right hand side view orthographic projections over here. And another thing we should remember over here, there is a rectangular slot available at the base of the solid at a height of 5 mm from the base. So this rectangular slot will not be visible to the observer from the right hand side orientation. So we are going to obtain the hidden line projections corresponding to this rectangular slot available at the base of the solid. So this way we have been able to obtain the orthographic front view projections of the engineering object, the orthographic top view projections, and the right hand side view projections of this engineering object. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the front view, top view and the right hand side view orthographic projections of the solid when the isometric 3D projections of the solid, they have been provided to us. So we are going to continue with further discussion regarding evaluation of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.